Hi there, in the last video I explained the Trapezium and Simpson's rules. Okay, and in this video I'm going to go through some examples in order to show you how these rules are applied. So, straight to the first example. Here's example number 1. Let me underline this. So, with example number 1, we need to find, so the question is defined, and we need to find the value of this integral, which I'm calling I, okay? And the integral is the integral between limits 1 and 2 of e to the power x over the square root of x squared plus 1. Okay, with respect to x, and we need to calculate that integral correct to 3 decimal places, okay, using the following methods. And in part A, we're going to be using Trapezium rule. So part A, Trapezium rule with 5 ordinates. And part B, Simpson's rule with 5 ordinates also. Okay, so let's do that. So for the Trapezium rule, okay, and Simpson's rule, so they're both, we need to calculate the answer for this integral using both of the rules with 5 ordinates. Remember, 5 ordinates implies the value of capital N. So in the last video, I mentioned the idea of N. N is the number of ordinates, and the number of ordinates in this example here is 5 for both. Okay, so in this case, N is 5. So capital N is 5, okay? Now, if we focus on the integral itself, the lower limit is 1, so the lower limit corresponds to the value of small a, okay? And I'll explain small a, the idea of small a soon, okay? And the upper limit relates to the value of small b, okay? So let me make a quick note. A equals 1, B equals 2. We need these values in step number 1. Now step number 1 for me, so let me underline step 1, is to work out h. And h is the width, okay? So when it comes to the Trapezium rule, okay, h is the width of a trapezia. So the formula for h is b minus a divided by n minus 1. So let me apply that formula here. So let me write down the formula firstly. B minus a over capital N minus 1. And if I replace the values, b is 2, minus a, which is 1, divided by capital N, the number of ordinates 5, minus 1. And you should have an answer of 0.25. Okay, so that is step number 1 to work out h. Okay, now we need h first of all in order to work out the x values, and if you remember in the last video, we need the x values to work out the corresponding y values. Okay, so when it comes to step number 2, so let me continue here. So let me take a red pen and a ruler. Now in step number 2, let's work out all of our x values. Okay, so in this case, starting with x0, so x0 is the value of a, okay, and a in this case is the lower limit, so the lower limit is 1. Okay, we can calculate y0. And to work out y0, we have the function for y. So the function for y within the integral is e to the x over the root x squared plus 1. Okay, so let me note that down in the corner. Remember, y within our integral is given e to the x over the root x squared plus 1. So for y0, all we do is replace the x0 in our function for y. So we're going to have e to the power x0, which is 1, divided by the root of x, which is 1 squared plus 1. Okay, and I worked out that value to be 1.922. Okay, so that should be the value of y0. Now, let's calculate the remaining x values. Now, the next x value is x1. And if you remember in the previous video, each of the trapezia has equal width. So if the width of the trapezia that we worked out, h, is 0.25, the next x value, which is x1, x1 will be the previous x value plus h. Okay? So x1 will be x0 plus h. Okay, so x0 is 1 plus h, that was 0.25, giving us 1.25. Okay, so that's the value of x1. Now, if to calculate y1, straightforward, replace the x value of 1.25 in the function for y. So we're going to have e to the power 1.25, okay, divided by the root of x, which is 1.25 squared plus 1. Okay, so I worked that out also, so I worked it out as 2.180. Okay, now we need to continue calculating the x values and the corresponding y's until we reach the last value of x, which is the value of b. Okay, and bearing in mind that the last value is going to be 2. Okay, so we need to keep on calculating the x values until we reach the last one, which is x equals 2, or x to be the b value. Okay, so if we continue the process, x2 is x1, the previous value of x, plus h. Okay, so x1 is 1.25 plus h 0.25, that gives us 1.5. And if I replace x by 1.5 in our function for y, y2, the corresponding y, will be e to the power x, which is 1.5, okay, divided by the root of x squared, which is 1.5 squared plus 1. Okay, so I worked out y2 as well. I had an answer of 2.49 for y2. Okay, so if we continue, because we haven't reached the final x value, the final x value is the value of b, which is 2. So let's continue. So x3 will be the previous value, which is x2 plus h. x2 we had 1.5 plus h, that was 0.25, giving us 1.75. So for the corresponding y value, y3 will be e to the power x, which is 1.75, divided by the root of, and in this case x, which is 1.75, not forgetting to square, plus 1. So for this value I had y3 to be 2.855. Okay, so let's calculate another one. We haven't reached the value of b, which is 2. So x4 is the previous, x3 plus h, x3 we had 1.75 plus h 0.25. That gives us 2, as you can see. So we reached that final x value. Okay, so remember the final x value is the value of b, which is 2. And let's work out the corresponding y value. y4 is when I replace x by 2 into our function for y, e to the power x, which is 2, over the root x, which is 2 squared, plus 1. Okay, so for this value I had 3.304. Okay, so remember you need the y values, okay, for the trapezium rule, okay, and we're going to use the same y values for Simpson's rule as in the problem in parts A and B. Trapezium and Simpson's rule, they say that we need to calculate the value of this integral using the same number of ordinates. Okay, so you can use the same data in this case, okay, in order to work out the value of this integral using both Trapezium and Simpson's rule. So watch out for the number of ordinates. If the number of ordinates is different, then the data will be different. Okay, so since the number of ordinates in this example is the same, and since we're using the methods on one integral, okay, you can use the same data in both the trapezium rule as well as Simpson's rule. So let's go ahead. So that is step number 2, and in the final step, step number 3, let's take a red pen and ruler. Now let me do a quick check before I apply the rule. So 5 ordinates implies 5 x values, which corresponds to 5 y values. So let me check. So x0 is the first one, so 1, x1 is 2, x3 is the third, x4, the fourth value is x3, and the fifth value x4. So I've got 5 x values from x0 to x4, so I'm okay, yeah? And in this case I've got all of my data, so before you use the formula, double check your data as well, okay? So let me use firstly the trapezium rule. So this is the solution to part A. Firstly, let me write down the formula. So the integral I will be, remember for the trapezium rule it's h over 2. So it's h over 2, open a bracket. And remember in the previous video it's the first y value plus the last y value. So first y value is y0 plus the last y value, which is y4, plus 2 times the sum of the remaining y values excluding first and last. So sum of the remaining y values means y1 plus y2 plus y3. Okay, so I would encourage you to write down the rule first and then substitute the data. So h is 0.25 divided by 2. Let's open a bracket. y0 is 1.922. So let me tick that. Let me tick as I substitute the values. Plus y4, 3.304. So 3.304. Plus 2, open a bracket. y1 is 2.180. So 2.180 plus, and y2, 2.49 plus y3, 2.855. So 2.855. Okay. And I've calculated this. So the value of I, so for me, when I calculated this in the calculator, I had an answer of, using the trapezium rule, 2.534 to 3 decimal places. Okay, what I would say is when using your calculator, be sure to use the same amount of brackets as I've written it down. Okay, so use the same amount of brackets so that you get the correct answer. Okay, sometimes if you don't place the brackets in the right areas, you might have a completely different answer. Okay, so be sure to be cautious when you compute this using your calculators. So that's the answer using the trapezium rule. Let's use Simpson's rule now. So here's part B. So using Simpson's rule, so I is going to be, remember the formula for Simpson's rule, it's h over 3 this time. And let me remind you, so in a previous video, it's h over 3 multiplied by first y value plus the last y value plus 4 times the sum of the odd y values excluding first and last plus 2 times the sum of the even y values excluding first and last. Okay, so bearing in mind that, let's write down the rule first. So it's going to be the first plus the last, so y1 plus y4 plus, remember, 4 times the sum of the odds, so we have y1 and y3 only. Okay, so going back, y1 plus y3 plus 2 times the sum of the even excluding first and last, so the only even that I have is y2. Okay, so multiplied by 2 times, let's go back, y2. So first write down the rule and then substitute your data. So h was 0.25 divided by 3. y0, let's go back and remind ourselves, y0 was 1.922. So 1.922 plus, and y4, let's have a look, we had 3.304, so 3.304 plus 4 into, now y1, so y1, let's go back, 2.180, so 2.180 plus y3 was 2.855. Okay, so 2.855 plus twice of y2, and that is 2.49. So 2.49. So I calculated this, and in the calculator I had a final answer of 2.528 to 3 decimal places for Simpson's rule. Okay, so here are the steps for the example. So here are the steps for both the Trapezium and Simpson's rule. Okay, and yes, that completes this video.